All right, guys. This is our next section that deals with area. This is going to be related to finding the areas and perimeters of similar figures. Okay, so we're going to start off with an investigation. So we're going to draw a polygon or a circle, whichever you choose. I'm going to do a polygon on here. And we're going to calculate the perimeter and the circumference of this polygon. And we're going to keep it real simple. So let's just draw a rectangle. Okay, and this rectangle is going to be 1 foot by 2 feet. Okay, so 1 foot by 2 foot. So the perimeter we'll do first. The perimeter of this rectangle is 2 plus 2 is 4, plus 2 more is 6. So this is 6 feet. And then the area of this figure is 2 square feet, because 1 times 2 is 2. Okay, so there's the area and the perimeter of our first figure. Okay, step 2, it says dilate your figure by a scale factor of 2. Okay, so this is going to get 2 times bigger because it's a scale factor of 2. So let's draw a bigger rectangle. Okay, well, if it got dilated by scale factor of 2, now this is 2 feet, and this is now 4 feet. So let's find the perimeter of this one. So this is 4 and 4, that makes 8, plus another 4, because that's 2 and 2, that makes 12. So the perimeter is 12 feet. The area of this rectangle is 8 square feet, because we're finding the area. So let's study this a little bit right here. Okay, so all of these sides got twice as large. Okay, they got 2 times bigger. Let's look at the perimeter and see how that changed. It went from 6 feet to 12 feet. So what happened there? That got twice as large. 6 times 2 is 12. But what happens when we look at the area? The area is 2 square feet here, and the area over here is 8 square feet. Did that get twice as large? No, it did not. It got 4 times larger. Okay, so let's just stop on that right there, and let's go to the next step, and then we'll go back and figure out how these ratios relate. Okay, so one more time, it says now dilate your original figure by a scale factor of 3. Okay, so now a scale factor of 3. So this blue rectangle is now going to get 3 times bigger. Okay, so I'm going to try to draw a bigger rectangle as large as I can. And so now this is going to be 3 feet, and this is going to be 6 feet. So let's do the perimeter of this. So the perimeter is 6 and 6 is 12, plus another 6 is 18 feet. Now for the area is going to be 3 times 6 is 18 square feet. And yes, you can have the same value for the perimeter and the area. It's in different units. Remember that. This is 18 feet. Down here is 18 square feet. Okay, now, so I want to compare again back from the original. So these numbers got 3 times larger. How did the area get in terms of how many times bigger did it get? It went from 6 to 18. That's still 3 times larger, so the same as the scale factor of 3. And then the area went from 2 to 18. That did not get 3 times bigger. That got 9 times bigger. So let's look at that for a minute. So when we were talking about the area getting 2 times larger, I'm sorry, when we're looking at the area of this red rectangle, the area did not get 2 times bigger, even though all the sides and the perimeter did. The area got 4 times bigger. And then the area of this figure over here that got 3 times larger, this area got 9 times bigger. So 4 times bigger and 9 times bigger. How is 4 and 9 related to a scale factor of this one was 2 and the scale factor of this one was 3? I'm going to highlight those for a second. Scale factor was 2, the area got 4 times bigger. Scale factor was 3, and the area got 9 times bigger. So how is the 2 related to the 4 and the 3 to the 9? Well, all you have to do is you square the 2. 4 is the same thing as 2 squared. 9 is the same thing as 3 squared. So the reason why the area doesn't get twice as big like the perimeter did is because we are in a different units. So the area got 2 squared times bigger. The area for the green triangle got 9 times bigger, which is the same thing as saying 3 squared times bigger. Okay, so there's 3 ratios I want you to focus on. There's a side ratio, okay, and that would be A to B, okay? So the side ratio is going to be A to B. In this case, from the blue to the red, it was 1 to 2. And from the blue to the green was 1 to 3, okay? Now, there's a new ratio called the area ratio. The area ratio is not A to B, but A squared to B squared. You have to have them squared because you have the units that are now in squared units when you're working with area. Now, keep in mind, the side ratio is the same as the perimeter ratio because, let me get my highlighter. When we were looking at the perimeters, so the original perimeter was 6, and when we use a scale factor of 2, the perimeter was 12. It got twice as big. And then when the perimeter was 6 and we use a scale factor of 3, it also got 3 times larger. 6 times 3 is 18. So the perimeter ratio is the same as the side ratio because the sides got twice as big and then the sides got 3 times big, which is the same as the perimeter. The only thing that was different is this area did not. This was 2. It did not get 2 times bigger. It got 4 times bigger, or we will say 2 squared times bigger. And then over here, it went from 2 to 18. It did not get 3 times bigger. It got 3 squared times bigger. Okay, so we're going to do some problems working with area and similar figures. And you got to be able to use, and I really highly encourage you to work on using these ratios right here. Okay, and then I'm going to show you in these examples how to use those ratios. So we're going to do 3 examples with these right here. So the first one, it says, if the area of a triangle is 37 centimeters squared, what's the area of a similar triangle that has been dilated by a scale factor of 6? So dilated by a scale factor of 6. So let me get my pen. Okay, so you mainly need to remember we have a small triangle and then we're going to have a really big triangle. How many times bigger did that get? It got bigger by a scale factor of 6. So everything got 6 times bigger, okay? However, is the area going to get 6 times bigger? Well, and we just realized in our investigation that the area did not get twice as big or 3 times as big. It got 2 squared times bigger. So you can either choose to do a proportion, which I would highly recommend in a lot of situations. You don't have to in this one, but I do want to set up a proportion so you can see how that will work. So instead of saying 1 is to 6 as 37 is to x, we cannot use 1 to 6. We have to use 1 squared is to 6 squared as 37 is x. Okay, so the area of a triangle is 37. Let's make sure that's the smaller one. What's the area of a similar triangle that has been dilated by a scale factor? So right. So if you, and it helps to also write little things like this. So the area of this little guy is 37. What's the area of this guy? A lot of people are, all they're going to do is they're going to do 37 times 6 and put that answer there. That is incorrect. Okay, so I'm going to put a big X through that. Do not do that. But if you set up this proportion, this is easy to work with. So we're going to cross multiply here. What's 37 times 6 squared? That would be 1,332. And that's just 1 times x, so all you have to do is divide by 1. So it's 1,332 centimeters squared. Okay, so I didn't have to use the formula to figure this out. I just needed to use the correct ratio, and that's 6 squared. Now I know you can do 37 times 6 squared. That one would be correct, but please don't multiply it times 6, because if the sides get 6 times bigger, the area does not. Let's go to the next one. Let's try the next one. The next one, it says the area of a trapezoid is 48 centimeters squared. The area of a similar trapezoid is 432 centimeters squared. What is the height of the smaller trapezoid if the height of the larger is 24? Okay, so I'm a visual person, so I like to draw this. So I've got a small trapezoid and I've got a large trapezoid. This area is 48. This area is 432. The height of the larger one is 24. What is the height of the small one? Okay, here's what a lot of people will probably do. They'll say 48 is to 432 as x is to 24. What is wrong with that picture? This ratio right here is a ratio that you cannot use because this is units squared. Remember, this is centimeters squared. This is centimeters squared. So you cannot use that ratio. So how do we get the side ratio? How do you go backwards and get the side ratio? Well, how would you turn units squared into just units? How do you get rid of a squared? You have to square root, okay? So we have to technically square root that and square root that, but that doesn't look like a perfect square. So what I would suggest you do is reduce 48 to 432. So let me go ahead and erase this ratio proportion. That's no good. Okay, so here's how it would be a good way to write the ratio. So the area ratio is 48 to 432. What is that reduced? Well, they're both even, so it looks like it reduces. I'm just going to check to see if 48 goes into 432. And it does. This goes into it 9 times, so this actually reduces 1 to 9. So the area ratio, y'all, is 1 to 9, okay? 1 to 9. There's 2 ways you can write out a ratio, 1 to 9 and 1 to 9. So if the area ratio is 1 to 9, the area ratio is 1 to 9. We can't use 1 to 9. We have to use the side ratio. So what did I say a second ago you have to do? You have to square root both of those numbers. What's the square root of 1 is just 1. The square root of 9 is 3. So the side ratio is 1 to 3. That's the ratio that you want to use. All the sides and all the parts get 3 times larger. Okay, so you have to focus on and see how many times larger did this area get. The area got 9 times larger. Well, if the area gets 9 times larger, you have to square root that so you can see how many times bigger the sides get. And so the sides get 3 times larger. So you can do a ratio or you can do that in your head. A lot of y'all probably can figure out the height must be 8 because 8 times 3 is 24. Okay, so the height is 8. All right, one more. Let's try one more. Make sure you get used to using these ratios. It says the area of a kite is 56 inches squared, and one of the sides is 20 inches. What's the corresponding side length of a smaller kite if the area has been quartered? Ooh, okay, so it's been quartered. So how many times smaller did it get? If you take a quarter of something, that's like taking 1/4 of something, right? So that means the area is getting 4 times smaller. So let's figure out what these two areas is. So here's a kite, and this one has an area of 56. Okay. One of the sides is 20. We'll just say that side, it didn't matter. It says, what's the corresponding side length of a smaller kite? So now we're dealing with a baby kite, and we want to know what that is. So I'm going to put X because that's 20. And it says the area of this one got quartered. Okay, so what's 1/4 of 56? Does 4 go into 56? Yes, it does. So this area is 14. Okay, so what's the area ratio? The area ratio is 4:1. So what does that tell you the side ratio is? Because I bet a lot of y'all would want to put that this side is going to be 5. If the area got 4 times smaller, then the side's going to get 4 times smaller. No, it is not going to get 4 times smaller because we are in a different units. What do you have to do to the area ratio to get the side ratio? That's what you need to use. What's the side ratio? Whatever this is squared. Square root. So the square root of 4 is 2. The square root of 1 is 1. So the side ratio is 2:1. So what would that side be? It would be 10. 10 inches to be exact, because it said inches up here. This was 20 inches. That means this is going to be 10 inches because the side ratio is 2:1. If the area got 4 times smaller, the sides are not going to get 4 times smaller because this is, again, inches squared and inches squared. Right here, this is just inches. So you have to square root the area ratio to get the side ratio.